This is another video in which I'm going to be solving an integral in 3 different ways. I found this particular integral on Instagram, and I saw that the person who posted it solved it in a way that I would never have thought of to do it. It totally works, and it's pretty smart, but I just would not think of doing that. That's just from my experience and the techniques I'm more familiar with and much more competent in. I would choose one of the other techniques I'll show in a bit versus what this person did on Instagram. Okay, so let me show you what happened. So we have this integral of 2x cubed over x squared plus 1 dx, okay? This is not really clear, except to me, when I see something squared plus something squared, I'm thinking trig sub right away. If you don't want to do a trig sub, you can do what this person did. Again, I would not have thought of doing this, especially in a timed test scenario. I would not have thought to do this at all. Okay, but it's actually kind of clever, and it makes it pretty easy, actually. You just have to be able to algebraically manipulate the integrand. All right, so this 2 is a constant. We can pull it out, okay? So we could do a plus x minus x inside the integrand. That's just adding 0, so that's totally fine. Okay, why did we want to do that? Well, now I broke it up into 2 fractions here. Okay, this integral over here is easy to solve. That's just a substitution. Over here, what if we factor out an x? Well, it becomes x times x squared plus 1. These would cancel and you're left with x. Now this is 2 simple integrals to solve. Okay, this one's just x squared over 2. This one, as I said, is a substitution, so it should become half ln of x squared plus 1. You could quickly check by differentiating. You should get back that. Plus c, and then we simplify, distribute this 2. So you get x squared minus ln of absolute value x squared plus 1 plus c. By the way, you could drop the absolute value here because it's always positive, but I just kept it in there just by habit, okay? So this is what the person did on Instagram, okay? Here's a different way to solve this. You can do you could totally do a substitution. Again, we pull that 2 out first, and then this x cubed you could rewrite as x squared times x, okay? Why do I want to do that? Well, we can let u be x squared, du is 2x dx. So then we can substitute 2x dx as du, x squared is u, and then it's u plus 1 on the bottom. This, we can make another substitution. Let v, let's say, be u plus 1, dv is du, so then it becomes this over here. And then we can divide through by the v, so it becomes 1 minus 1 over v, dv. Now this is simple to integrate. V minus ln of absolute value v plus c, we back substitute twice though. V is u plus 1. And then u is x squared. Okay, so we get this over here. Oh, what happened? Doesn't quite match here. Well, this plus 1, you can lump it in with that constant c, so that's how we get it to match. That's method number 2. I would probably thought to do this instead of this. And actually, I would actually probably just directly went with trig sub because I see, and especially again, in a time test, I want to be, instead of trying to use a technique I'm not familiar with, I can use one that I'm very familiar with, like trig sub. Even though it's a little more tedious, I'm more confident that I will get the answer correct versus doing this weird not really weird, but it's not as obvious algebraic hack over here. Okay, so again, something squared plus something squared, I can do a trig sub, set up the triangle. We substitute everything in this integrand in terms of theta, so x cubed would be tangent cubed. Okay, dx is secant squared theta d theta, and then x squared plus 1 is secant squared. The secant squared will cancel. Now you got to be good with solving trig integrals here. What's the integral of tangent cubed? Well, tangent cubed I can rewrite as tangent squared and tangents. Okay, tangent squared times tangent, sorry. Okay, tangent squared I can rewrite as secant squared minus 1, distribute this tangent to both terms. This one is a substitution. This one you should just memorize. If not, you can also do a substitution. Okay, so we get this over here. Okay, and then we back substitute. By the way, you can distribute this 2, which is what I did. So what's tangent squared? Well, tangent is x, so tangent squared is x squared. Okay, what's secant theta? That is square of x squared plus 1. Okay, and then by properties of logs, this is x squared plus 1 to the half power. That half I can pull out in front, so half times 2 is just 1. Now we get a matching answer right here. Okay, so this is a third way to do it. Okay? Again, I personally would not have thought to do this, especially in a time crunch scenario. Instead, I'm going to either do this, but more likely I'm going to do this because I see something squared plus something squared, okay? Another technique that you can use, which I didn't even do here, you can do long division of this rational function, can you not? So if you do long division, you might get something more close to this right here, actually, and then you can integrate. So maybe let me do that live, actually, for you. Okay? So, okay, if we want to divide these two, so we have x cubed, that 2 is a constant we can move out, right? So x squared plus 1, okay? Let me do this live for you. So this would be x, so minus x cubed plus x, so it becomes minus x. That's the remainder, right? So the integral I would be x minus x over x squared plus 1 dx. And isn't this exactly what happened over here? So actually, maybe doing long division is actually the most efficient way, instead of doing this weird algebraic hack over here. You get this, and then this is just x squared over 2 minus ln of x squared plus 1, but then that doesn't seem right because I need a half out here, right? Plus c, does that look more right now? And then there was a 2 out in front, which I missed, so that's why. So then 2 times this plus c, so then it's x squared minus ln of x squared plus 1 plus c, and then same answer still as that, right? So this just goes to show maybe long division is actually the best way to do it. I know a lot of people don't like long division, but it's actually, look, much faster than even this. Look how many steps I had to show here. You could probably skip some steps at this point in your math career, but to be safe, of course, you should show more steps. So look how many I had to do here versus a simple long division. Only a few steps. Okay, so actually I solved this in 4 ways now. So pick your poison, basically. Obviously, one's not as poisonous as another, if you want to think of it like that. This was the least poisonous one, and it was the most efficient, okay? So maybe you should go with this one. But again, just me, personally, I would have probably gone with the trig sum method, even though you can see it's quite tedious. But again, I'm more confident that I would get it correct with trig sum. And especially in time scenario, I see that you can solve it with trig sum, so I'm going to go with that instead of thinking, oh, should I do this weird algebraic hack? Will it work? Is it going to waste time? And all that. Okay? So hopefully this was helpful again, so that you can see how to approach this one simple integral in 4 different ways.